previous video, we looked at the XAML code to create our user interface for the sliding tile puzzle project. In this video, we'll look at the underlying C# code to provide the functionality. We'll randomly set up the game for the user, handle the gameplay in which they can click on any square next to the open square and swap the tiles or slide the tile, check to see with each move whether they've won the game or not, track the number of moves, track the elapsed time, give them feedback when the game is over, and allow them to either play a new game or replay the same game again. Let's take a look at the code. At the top of our C# code, I added a systems diagnostic directive which gives us access to the StopWatch object that we'll use in tracking the time. Then within the main page class, I have three lists that are class level. First one is of type image button. It's named tiles, and that's going to contain a reference to our 16 different tiles so we can easily iterate through all the tiles. The next one is of type image source, and that's going to contain the source that should be on each tile if the puzzle is solved. So we'll set that once. It will not change, nor will the tiles change. And then the list of type image source named saved setup is going to contain the images that are placed on each of the tiles at the beginning of the game. And we'll be able to use that then to replay the same game, just iterating through the tiles and setting each tile to that original image source from the game before. I'm going to track the number of moves with an integer variable called moves. I'm going to keep track of which tile is the blank tile, and in the solved situation, it's going to be number 16. That's where we're going to start. The image buttons are set up in XAML so that they are in numerical order with the blank one on number 16. And we're going to slide those around to create our new game. But we want to keep track of where the blank tile is. That'll also come in handy when we're trying to swap a tile, make sure that it is next to the blank tile. And then I want to set that blank tile up also in the replay so that if we've solved the game, the blank tile is going to be number 16, but if we replay, we want to reset that blank tile to whatever it was in the original setup of the previous game. We use a random object to randomly slide our tiles. And then I have an IDispatcherTimer that we're going to use. It's integrated in the main thread, but runs on a dispatcher queue so that it generates a tick event at a processed interval of time. And we're going to set that up to be 1/100th of a second, or 10 milliseconds. I have a variable that's of date time called start time. That's just going to basically specify when we start the clock, and we'll use that in our math for elapsed time, and then our stopwatch object, which we'll use to make it a little bit easier to do the math. In our main page constructor, after we initialize the component, we want to populate the tiles and solution list. So I'm going to set up a temporary array of type image button that contains the 16 image button references from the XAML. So IB tile 01, 02, and so forth. Notice that 01 is repeated twice. So to make this a little bit simpler, I'm not going to use index 0, but I have to have one. So I set index 0 and index 1 to be the same. We won't iterate through tiles 0 through 16. We'll iterate through tiles 1 through 16 in our indices. And that's what we do after we clear our tiles and solutions. So the tile simply eliminates anything those list serves. And really there shouldn't be anything there at this point. It's just good practice. And then we're going to iterate through our loop for int 0 through 17. We're going to set the indice of each one to the temporary image button reference of temp IB. And we'll do that both for tiles and for solution. Solution, though, we're setting the source of that image button. That's going to give us 1 through 15 numerically with the blank button at the end in the bottom right corner. Going to set up my timer. We're going to set the time span being 1 microsecond. Then I used a lambda expression. You probably have not covered that in your previous C#. We do cover it a little bit in the advanced C# class. If you're taking that concurrently, we haven't gotten there yet. Lambda expression is basically an unnamed method. In this case, we're adding a method to an existing method for the tick event. And you'll see plus equals, we're adding to it. The SE is our sender and event args parameters. And then the equals greater than is referencing the the method, and all we're doing in the method is just simply calling update clock. We could do a whole bunch of stuff in that method. In this case, we're just calling another method. That update clock with each tick will update our clock and display the label of the elapsed time. So that should happen every 1/100th of a second. I created a method called swap tiles, and there all I'm doing is passing two integers, which are going to be the indices of our tiles list, and we're simply swapping those. So we're setting a temporary image source to the first one, putting the second one in the first one, and then adding that temp to the second one. So that will swap the two images between the tiles. Then for our game setup, we're going to do this randomly. I'm going to display that overlaid image called IMG weight new. It's going to hide our tiles for the most part. So setting that is visible to true. I'm going to show the progress bar. So progress setup.isVisible equals true. We're going to set the progress level to 0. We'll update as we iterate through the loop of doing we're going to do 200 moves randomly of our tiles to ensure that we get a solvable puzzle. In the past, I've created this in another system where I just randomly placed the images or the image tiles, and once in a while I'd come up with one that actually the game was unsolvable. So I thought, well, how do we do this in real life? We would simply have somebody slide all the tiles for us and then hand us back the puzzle and we solve it. That's what this does. It's going to randomly slide those puzzle pieces or those tiles for us and hand it back to us to play the game. So we have a loop. First of all, I'm going to reset the tiles all back to the solved state. And I have a method that does that. In essence, we're calling that solution and resetting the tiles to each tile of that solution list. And then here's my loop. We're going to go from 0 to 199, so 200 times. We're going to check to see what the blank tile is. We're going to start with it being in the bottom right. And there's two possibilities. We can either slide the tile to the left of it, or we can slide the tile that's above it. So tiles 15 or 12. We're going to randomly choose which one of those two using our int a equals rnd.next2. And then I simply have a couple of if statements here, and I wrote those on one line just to reduce the amount of length of my code. So if a is equal to 0, then we're going to swap the blank tile to 15. If it's equal to 1, we'll swap the blank tile with 12. We want to make sure we always update the blank tile because we're going to use that in the next move. For cases 14 and 15, it's basically the same thing. We can either slide the tile that's to the left, the right, or above it. And just do a little bit of math there. So if it's to the left, it's going to be blank tile -1. If it's to the right, it'll be blank tile +1. And if it's above it, it'll be blank tile -4. Just using the numbers 1 through 16 laid out in a 4x4 grid. So there we have three possibilities. Case 13, that's the bottom left corner. There we can either go to the right or above. And then I'm swapping tiles 9 or 14. Then for case 12 or case 8, this is going to be on the right-hand edge in the center two rows. We can either go to the left, we can go above, or we can go below. And again, just doing the math there. And then I continue doing that same process for all the other possibilities. So 9 and 5 are the tiles on the left. Case 1 is the tile in the upper left-hand corner. We can go right or below. Case 2 and 3 are the tiles at the top in the two center rows of our tiles. And case 4 is the blank tile being in the upper right. And we can swap either to the left or below. The default, though, is those tiles in the center of the puzzle. There we can go left, right, above, or below. So we have 4 possibilities. With each iteration, we're going to update our progress for the progress bar by taking I and dividing by 200.0. Remember, we're in a double value there. The progress is a double value. And then to force our screen to refresh, a little trick here is I'm going to wait the task delay of 10 ticks. Now note that this is an asynchronous method. So when you use a wait, you've got to make sure you use async in your method designation. Set the moves equal to 0 once we've iterated through all 200. We're going to update the label. We're going to store the setup. So I'm calling a method called store setup that basically sets the saved game tiles to the current tiles that we've just moved around. I'm going to hide our progress bar and our image. The game will now begin, so we're going to start the clock and set the timer to start. That start the clock is another method call. We're going to pass it a Boolean expression of true, and we'll look at that in a sec. So here's our reset tiles that we called from above. Here we're setting the source of each tile to the image of slider underscore and then whatever the index value is. The D2 there gives us two numbers. So if it's a 1, it'll be 01. If it's 2, it'll be 02. So always have two numbers. And then underscore tile.png. Set the source of the tile. And then we want to make sure that last one is slider 00 underscore tile. And yes, alternatively, I could have just swapped the solution tiles into the tiles source. That may not always be the case though, so I wanted to show you how you could do that iterating through the tiles and concatenating the names of your graphics. So a couple of different ways we could do that. Store setup. Here's where once we've set up our new game, we're going to place each of the images from our tiles into that saved setup list, clearing it first and then iterating through those, and make sure we're setting the blank replay to the blank tile. Our replay button is taking those saved tiles from our saved setup list and applying the images to our tiles element I source in a loop we're iterating 1 through 16. Resetting the moves, making sure the blank tile is set to blank replay, and then set our lbl moves.text to the value of moves, two strings. We're going to put a 0 there. We're going to start the clock and start the timer. Now, as the user makes moves, we need to verify that the tile they clicked is next to the open tile. And we're basically doing this the same way as we did the swapping of tiles in the setting up of the game. I want to determine which button they clicked. So that's going to be our image button, IB target equals sender as image button. We're going to set a target num integer variable to 0, set the open space equal to blank tile. We're going to iterate through I being 1 to 16 in a loop, and we're going to get the tile. If the tile sub I matches the LBL target, then we know the target number is I. We're going to increment moves, and then we're going to switch on the target number, whichever number they click. So if it's a 0, it didn't match anything, which really should not be the case. We'll decrement the moves. We want to make sure that's covered. Then case 16, so they clicked on the bottom right. If the open space is above or to the left, we'll swap the tiles. Case 14 and 15, if the open space is left, right, or above, we'll swap the tiles. Case 13 is our bottom left-hand corner. If the open space is to the right or above, we'll swap those tiles. So basically doing the same thing we did on the setup. We were swapping the click tile with the tile next to it only if it's empty. Case 12 and 8 is on the right-hand side. Case 9 and 5 are on the left-hand side in the center. Case 1, upper left. Case 2 and 3, two center tiles on the top row. Case 4 is the upper left tile. And they're swapping if the open space is to the left or below. And then our default are those tiles in the center that are not on a border or on the edge. We're going to increment moves. We're going to show the moves, update that label. We're going to delay our task by 10 ticks. And with each move, we want to check for win. Again, that delaying a task is just there to force our screen to refresh. And once again, since that's an await, we have an async modifier on our method. Check for win is also going to be an asynchronous method because we're going to use the display alert, which occurs on another thread. Here we're going to have a Boolean expression called winner equals true. We're going to go through each of our tiles I through 17. If any of them do not match the solution tile, we're going to set winner to false. Otherwise, we keep it as winner. So I used a ternary statement there. And then if winner is true, we're going to stop the clock. We're going to send the start the clock false. and we're going to display an alert with the title of Outstanding, text of You Solved the Puzzle, and a button that says I'm good. Here's our Start the Clock, passing it the bool value of running. So if that is true, we're restarting the clock. And I used sw.restart instead of start because that resets the elapsed time to 0 and begins the clock. If that is false, that's where we're going to stop the clock. So we're going to have our else fork, our sw.stop, sw being our stopwatch object. Time span will be the time taken.sw elapsed. So again, just a nice elapsed method in that stopwatch. It'll give us just the elapsed time. And then we're going to format that for minutes, seconds, and hundredths of a second. And then display that in our label called elapsed. For update clock, we're going to call that with each tick of our display. Remember that was in our lambda expression. We're going to calculate the elapsed time from our stopwatch, format that for minutes, seconds, and hundredths of a second, and show that in our LBL elapsed label. I have another little method here that I've commented out. I kept this in because I want you to know that sometimes I just want to test something. And so I'll write a method to test something, see if it works. And then I can always just comment it out or delete it. Sometimes I leave it in, commented, just for reference purposes. And this was a test of seeing what images were located on which tiles at the start of a game, using a display alert and string builder to create the prompt. If you just jumped into this video, you can see all the videos from the .NET MAUI Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.